Our story begins with two Jedis at the Mos Eisley Cantina, Obi-Wan Kenobi and Qui-Gon Jinn.
You want to hear a great joke I got told the other day?
Yeah.
So, what program do Jedi use to open PDF files?
I don't know.
But Obi-Wan Kenobi! Oh, God.
Oh, you're getting a call on your phone.
Oh, wow. Alright.
What is this?
Hello, gentlemen. I assume you are the two Jedi I'm looking for.
We aren't the Jedi you're looking for.
2 hours later.
Just kidding. How'd you know?
Well, you are the only two nerds sitting at the bar not drinking.
We are Jedi, you know.
Alright, anyways. The council wanted me to pass on a crucial tidbit about the you-know-what.
The what?
The last Sith, you bantha fodder.
So, you have information on the last Sith.
Well, I can certainly point you in the right direction. However, I cannot accompany you on this journey. I'm only a bounty hunter, and I could never take on a Sith Lord. The Force is strong with you, and I trust that you are ready to fight him.
So what do you know?
You must learn some basic nuclear chemistry if you want to destroy him.
Where did you gain such forbidden knowledge?
I was taught by the greatest alchemist to ever live, Master Kemmer.
Fantastic. Can you teach us now?
I'm sending through some images that will help you understand nuclear chemistry. According to the Council, the ion thrusters on his ship emit positrons. This is referred to as beta plus decay. In beta minus decay, a neutron is lost and a proton appears, and the process produces an electron and an electron antineutrino. The Sith Lord's lightsaber crystal emits alpha particles. This is referred to as alpha decay. An alpha particle consists of 2 protons and 2 neutrons. The Sith Lord cannot withstand gamma decay for any extended period of time. A gamma particle is a pocket of high-energy photons, and stars give off gamma radiation in high amounts. You will have to find him on a planet with a fairly thick protective atmosphere. Electron capture occurs when an electron is drawn into the nucleus. It combines with a proton, forming a neutron and a neutrino.
So this problem states a 2.5 gram sample of an isotope of strontium-90 was initially found in 1960. The half-life of strontium is 28 years. In what year will 0.625 grams of strontium-90 remain? So what you want to start off with in this problem is to try to find the K, the rate constant of decay, for strontium-90. To do that, you need to do half-life equals 0.693 divided by K. So we already have the half-life, which is 28 years, equals 0.693 divided by K. You solve for K, and you get 0.02475, which is a rate constant. Now, you use it in the formula a sub 0 equals a sub n times e to the negative kt. So your a sub 0 is 2.5 equals 0.625 times a sub 0, because it's 0.625 grams that remain, times e to the negative kt. So now, you want to divide by 0.625, and you get 4 on one side equals e to the kt. So 4 equals e to the kt. You take the ln of each side, you get ln of 4, which is 1.386, equals kt. You divide by K, which is 0.02475, and you get 56 years. Add that to 1960, and you get 2016, which is, ironically, this year.
The two Jedis travel across the galaxy to the distant planet Nucleo. They hope to find traces of the Sith Lord. In this problem, Calcium-41 undergoes positron emission, meaning it gives off a positively charged electron. When it does so, the proton number drops by 1. The element with 19 protons is potassium, so the element becomes potassium-41. Because the electron has no weight to it, it does not affect the 41 aspect of calcium.
We're picking up high levels of positrons coming from the Sith Lord ship, which indicates that he may possibly be on this planet.
You're gonna test this planet for gamma radiation? Because a Sith Lord can only withstand certain amounts of gamma radiation.
Here we see a metastable nuclear isomer of technetium-99. This atom gives off a gamma particle, which is basically a pocket of electromagnetic energy, and it becomes a stable technetium-99.
These levels indicate the Sith Lord may very well be here. It's definitely safe for such a Sith Lord.
The bounty hunter said that the crystals in Sith lightsabers give off high amounts of alpha radiation, so everything else on this planet lines up for him to be here, but there's no alpha radiation, he can't be here, so let's test for it.
When plutonium undergoes alpha decay, it emits an alpha particle. An alpha particle consists of 2 protons and 2 neutrons. If you subtract these 2 protons and 2 neutrons from the plutonium atom, as shown in this problem, you will get the element with 92 protons, which is uranium, and the number of neutrons would just be 2 less than 239. So your final element is uranium-235.
It's off the charts, he has to be here. Let's go.
Dead. I guess I have to take on the Sith Lord alone.
Man, I can't find him anywhere.
I am the Sith you are looking for.
Who are you?
You've been very clever, young Jedi, using the tactics of nuclear chemistry to track me this far. You were taught by Master Kemmer, I presume?
Yes, he was a fantastic teacher.
He was a partner of mine. His bad puns led me to the dark side, and now I thirst for revenge. I am Darth Maul!
The last Sith destroyed. Order has been restored to the galaxy until the end of time. Now, there's only one thing left to do. We gotta bury him!